Hi, my name is Krish, and I provide a cost-effective and worldwide accessible solution of parking using machine learning and edge devices. Have you ever decided to visit a popular place only to not find parking? Recently, I struggled so much to find parking near a medical clinic that I had to cancel my class afterwards. In the Bay Area, whether you want to dine in Santana Row or find parking near your home, millions of people in our region are inhibited by a lack of parking. When finding parking, people drive in circles at slow speeds on curbs and in parking lots, creating congestion and traffic, which is both an inconvenience as well as being harmful for the environment. 30% of all road vehicle emissions come from drivers trying to find parking. There are over 2 billion parking spaces in the United States, but most are underutilized. Allocating parking is a problem, not adding more. The problem is not just restricted to California, as less technologically advanced societies also struggle with parking. And that's why I created Find My Space, an app that aids drivers in finding available parking so that drivers do not spend unnecessary time circling unavailable parking lots. Although in the Bay Area there are effective methods to detect parking, such as parking meters and in-ground sensors, these cost hundreds of dollars per space and are only feasible in the urban areas. In the Saratoga Springs County, their sensors cost upwards of $718,000 per year. For my app, I've created a convolutional neural network that, when given a parking space, can predict its occupancy status. To do this, I found a dataset with over 12,000 crop pictures of parking spaces, which included obstacles such as trees and lamps. I decided to use the MobileNet V2 architecture due to its small size and high accuracy, perfect for an app or edge device. I trained my model with TensorFlow and tested it on over 1,200 images, tuning it until I got above a 98% accuracy for both free and busy spaces. I then combined this with the Raspberry Pi 400 and web camera. I went to a local park and took pictures of the parking lot with my camera, cropped each parking space with a couple of clicks, and then put each space in my model to generate results. Using my model, any smart camera, like a surveillance camera that overlooks a parking lot, can be used to get occupancy status and results from many spaces at once. With overcrowding in East San Jose, residents currently struggle to park their cars near their own homes, and they need a cheap house solution quickly. I then created a simple website that gives information about the parking crisis and an area for users to test my model. By clicking on the model button, users can enter any image of a parking space, and my model will either output free or busy. As you can see, I inserted this image of a parking space, and my model correctly predicted that it was free. My plans for this app are, first, to create code to automatically crop each parking space from a parking lot using segmentation. Then I want to use regression to allow my model to predict when parking spaces are most likely available using the timestamps on the dataset. Then, I plan on adding a feature where users can enter any destination at any time and get the closest parking spaces available. This does require access to more smart cameras, but I already have the foundation for it with my model, dataset, and edge device aspects. I hope my app will be a useful tool for a range of individuals. Visit my website at findmyspace.xyz and try it out for yourself. Thank you for listening.